In this video, we're going to be discussing a combination of topics, minimally. We're going to be talking about electricity, obviously, and the uncontrolled electricity that's static in the air, like when you walk up and touch a doorknob and you get that little shock, and the controlled electricity, which is in your blow dryers and your curling irons, and the electrical tools that we use. Now, as you go back into studying electricity, you cannot separate it out from chemistry. Chemistry and electricity go hand in glove because of the positive, negative ions that are in the elements. When we're talking about protons, electrons, and neutrons, we're talking about the electrical charge that are in some basic elements. The elements that we're concerned with are, the acronym is CONS, COHNS, and down here I have them separated out because carbon has 4 positive ions that are available for attraction. So when we're talking about a free electron versus a bound electron is part of the atomic structure of the actual atom and cannot be separated out, and you still have that element. The free electron can come and go. It's not part of the ionic configuration, it's extra. And so in carbon, you have 4 extra positive ions that are available for ionic or chemical bonding. Oxygen has a -2. In other words, there are 2 negative ions available. Hydrogen is a +1. There's 1 hydrogen available. Nitrogen is neutron, +3, -3. And sulfur is a -2. These are the elements that your body needs to make skin. So in the Cosmo 20 section, you have a video on how the structure of the skin. There's also the structure of the hair, and those you kind of need, and they're available on my YouTube channel, Susan I. James, Santa Monica College. So if you're not in my Cosmo 20 class, you can still go to the YouTube channel and have access to those videos if you would like. The covalent bond versus a polar covalent bond versus an ionic bond could get very confusing. Once again, this is not necessarily state board material, but this is necessary for you to understand how everything kind of works together. So a covalent bond would be like an oxygen tank full of oxygen. That's where the negative ions are shared. There's no other ion available. Oxygen is negative. All of the oxygen in that tank are called covalent bonds. Co and valent because they work together. In a polar covalent bond, they're still sharing electrons, but now because it's a polar, like as in Santa Claus, North Pole, South Pole, okay, we have a positive pole, we have a negative pole. So a polar covalent bond is like water. Oxygen is negatively charged, so there's 2 negatives here that look like little eyeballs. The O stands for oxygen. It can be the little guy, little Mickey Mouse's mouth. And then the hydrogen look like Mickey Mouse ears because the positive hydrogen attaches to the negative, positive to negative, giving me a polar covalent bond because electrons are still shared. When we step over into ionic or chemical bonding now, we create the chemicals that we actually use, like NH3, which is ammonia, NaOH, which is your sodium hydroxide, H2SO4, which is sulfuric acid, and those types of chemicals. And that's important that you kind of have an understanding of how it works together, because in the last weeks when we did the nerves and how the sensory receptors in the skin respond, you can see how this all kind of comes together, and it should start to make sense. You may need to go back and re-listen to the video on the nerves so that you have that concept refreshed in your brain as you come back and we talk about the bonding. The reason this is kind of important is because when it comes to the hair structure, okay, the cuticle layer of your hair is composed of hydrogen bonds, which are positively charged. So when you brush your hair, you get that static electricity, hair goes flying out. When you use your ionic tools, the purpose of ionic tools is to help you control the hair. Now, what you have to remember is that the client's hair style and what she wants are very important. If you were to use a negative flat iron on me, my hair would lay close flat to my head and I would be a very unhappy client. Okay, likewise, if I had 16,000 pounds of hair and you made me look like I had even more hair, I wouldn't be happy with you either. So I have to understand what style the client wants. Do we want it close to our head or do we want poofy? So if we want poofy, we use our regular blow dryers and we use our regular curling irons. But if you want it close to the head, now I need to step into my flat irons that are negatively charged. My blow dryer is the first step that I do. Obviously, I have to blow the hair, and I better put an R up there or you won't know that's a blow dryer. When I'm blow drying the hair, an ionic blow dryer works on the principle of the negative ions in the blow dryer attaching to the positive ions in the water molecule. It breaks the water molecule apart so that it will evaporate faster. But I'm still working on evaporation, and I'm still going to be blow drying my hair, and it's going to take time. But with the ionic blow dryer, it breaks it in half. Now, does it matter if it's a positive ionic? No, that's fine. Because if it's positive, it's going to hook onto the negative molecules of the oxygen. It will still break the molecule apart, and it still works on evaporating. Now, as soon as I add the far infrared to my ionic blow dryer, I change the concept from evaporating the water to changing it to a vapor. Now, that's all explained in your Module 2 handout, where you can go back and you can actually read it. Because a lot of times you want to know, is this a hype? Is the manufacturer trying to sell me something I don't really need? But if you understand the electricity and the chemical composition of the hair and the water molecule, then you understand how it works. Okay, ionic blow dryers work on the principle of breaking the water molecule in half so evaporation happens at a much faster rate. It will cut your blow drying time in half. Now, if I add this far infrared element to my blow dryer, I'm going to change from evaporating to a vapor, and you can actually see the steam leave the hair. And what that does is it dries it even faster, yet it leaves the moisture inside the medulla of the hair shaft, so I won't have dry, brittle hair anymore. My flat iron now works on the principle. I have two types of flat irons. One is non-ionic. It's not ionic at all. It's just electricity. And that's something you use on somebody who has medium to fine hair where they want it straight, but they don't need flat. They're already flat. They don't have enough hair already. Okay, so I don't need to add the concept of the negative flat iron. A negatively charged flat iron neutralizes the positive ions on the hair shaft, because remember, positive repels each other. That's where I get my static electricity. When I come through with a negative flat iron, it neutralizes the positive ions on the hair shaft, and it lays flat and close to my head. Okay, the ion theory is not a hype. It is actually scientifically proven that this works. And it's important that you understand so you know which tool to choose to use on the client for the style and the look they want to achieve. The tool is never wrong. Okay? Tools are never bad. It's not the car that's at fault. It's the driver. Okay? So when you're using your tools, if you don't understand the concept and you're not choosing the right tool to get the look you want, then you'll have a tendency to say, this flat iron's worthless, I don't like it. Not the flat iron. I just wasn't using it to its optimum benefit to get the look the client wants. Some things are super important. When I'm working with the flat irons and blow dryers, mostly the flat irons, I have different types of alloys. They have tourmaline, and when you're looking at the tourmaline blow dryer, for instance, the stone tourmaline, if it's an actual rock, has a positive end and a negative end. So a blow dryer that uses a tourmaline stone on the inside, to get positive, I push the switch up to positive. The airflow is going to come around the positive end of the tourmaline stone and come out with positive ions. If I have the negative choice on there, it's going to come around the negative end of the stone and pick up the negative ions. So I can have blow dryers with a tourmaline stone, and it's going to be my choice. If it says crushed tourmaline, then the positive and negative ions are all mixed together. You're not going to get either negative or positive. You're just going to get hot air, and that's okay too, if that's the choice you want. When it comes to my flat irons, I have a choice of tourmaline, I have a choice of ceramic, and the best alloy of choice would be your titanium. Now, titanium is the alloy of choice because if this were my, I should have brought a flat iron in. If this were my flat iron, this is the handle, okay, and this is the actual part that actually straightens my hair, okay, so that I get it straight. And this is ceramic. My heating element is right here, so it's hot here. Hot, okay, not quite as hot and not as hot. Okay, so if I start this way, I have hot, hotter, hottest. That means the hair shaft that I'm straightening doesn't have equal heat. So I have to keep going over and over and over it so that I can actually flat iron and get that hair straight, because the heat coming down the flat iron isn't equal. In titanium, you don't have that. Titanium is just as hot here as it is here. It's the alloy of choice for aircraft. If I'm taking off from Texas, where it's 120 degrees on ground, and my airplane takes off, and all that metal is 120 degrees, and it only takes me 5 minutes to get to an altitude of 10,000 where it's cold, to keep the metals from fracturing, getting metal fatigue, in titanium, the temperatures change immediately. Okay, and I don't have that stress factor. So a titanium flat iron is the better choice for you because I have equal heat. I can come down the shaft one time. I don't have to worry about the hair out here not getting as straight as the hair in here, which is going to save you time. Once again, all of this is in your Module 2 handout, and it's all explained in that segment on all of the tools. It explains how to use and choose your blow dryers, how to choose and use your flat irons, so that you're getting optimum hairstyling benefit from what you're doing. Now, when we're applying product to the hair, we need to make sure that our styling gels and aids have heat protectors in them so we don't overheat the hair shaft. Sebastian, when it was first formulated, was formulated to work in the movie industry. The woman who started Sebastian was working on the movie set West Side Story, and she told her husband, I need a hairstyling gel that when the hair is dry, it still looks like it's wet. Okay, so he developed the Sebastian product, and they named it Wet, because even when it's dry, it still looks wet. But she also told him, I need sunscreen and heat protectors in here because the hot lights from filming are damaging the hair, so I want my products all to have heat protectors so that the damage from the lights is minimal. And so almost all of Sebastian's original products were formulated to work with heat. Even though we didn't have the wonderful blow dryers and curling irons back then that we have today, the concept was still there. It's an external source of heat, and it's the heat that kind of damages the hair. So she wanted those heat protectors. So you want to make sure that the styling gels and products that you're using have heat protectors in them so that you're not damaging the hair shaft with your thermal work. Super important.